In the rapidly evolving landscape of manufacturing, businesses are increasingly recognizing the value of integrating information technology and operational technology systems. This fusion holds the promise of transforming operational efficiency and driving competitive advantage. However, many manufacturers continue to grapple with the challenges of merging these disparate systems, often resulting in fragmented operations that hinder overall performance. To fully harness the benefits of IT/OT integration, it is crucial to understand the underlying principles and strategies that facilitate seamless convergence. At the heart of this integration lies the programmable logic controller, a cornerstone of industrial automation. PLCs are specialized computers designed to operate in harsh industrial environments, executing control algorithms that govern machinery and processes. A key aspect of successful IT/OT integration involves the use of advanced software platforms for PLC programming and configuration. These platforms enable engineers to design, simulate, and deploy complex automation strategies, bridging the gap between IT and OT domains. By leveraging such tools, manufacturers can achieve greater visibility into their operations, enabling data-driven decision-making and predictive maintenance. To unlock operational excellence, we must delve into the core principles that facilitate seamless IT/OT integration. At the heart of this convergence lies the programmable logic controller, or PLC. Imagine the PLC as the central nervous system of your manufacturing plant, orchestrating every movement and decision in real time. It's crucial to use advanced software platforms for PLC programming and configuration. These platforms act as the bridge between IT and OT, allowing engineers to design, simulate, and deploy complex automation strategies. By leveraging these tools, manufacturers gain greater visibility into their operations, paving the way for data-driven decision-making and predictive maintenance. Ensuring compatibility and interoperability between diverse systems and devices is another critical aspect. This requires a robust framework for communication and data exchange, enabling real-time monitoring and control of industrial processes. Security is paramount. Manufacturers must protect sensitive data and prevent unauthorized access to critical systems. Consider a pharmaceutical manufacturing plant where IT systems for data analytics are integrated with OT systems for process control. This integration optimizes production workflows, reduces downtime, and enhances product quality. Real-time data from sensors and machines can be analyzed to identify inefficiencies and predict maintenance needs, leading to significant cost savings and improved operational performance. To begin the practical implementation of IT/OT integration, let's dive into the initial configuration. First, ensure your PLC firmware is up to date. This is crucial for compatibility with modern IT systems. Next, configure the communication protocols. For real-time data exchange, use OPC UA over Ethernet/IP. Set the baud rate to 19,200 for legacy devices, but for newer systems, 38,400 is more efficient. Remember, the keep alive setting should be enabled to maintain consistent communication. Also, allocate sufficient memory for data buffers to avoid overflow errors. Lastly, establish secure access controls. Use role-based permissions to limit access to critical systems. This ensures that only authorized personnel can make changes. And here's why that matters: secure, efficient communication is the backbone of a robust IT/OT integration. Now, let's dive into the practical steps for executing IT/OT integration strategies. The first step involves selecting the right software platform for PLC programming. Opt for a platform that supports both IT and OT functionalities, ensuring seamless communication between systems. Next, configure your PLCs to interact with your IT systems. This means setting up data exchange protocols, such as OPC UA or MQTT, to enable real-time data flow. Remember to address security by implementing robust authentication and encryption measures. Additionally, leverage advanced analytics tools to gain insights from the data collected. This will help you identify inefficiencies and predict maintenance needs, leading to optimized production workflows. And here's why that matters. By following these steps, you'll not only enhance operational efficiency but also pave the way for innovation through technologies like the Industrial Internet of Things. To optimize IT/OT integration, consider the nuances that can significantly impact efficiency. First, fine-tune communication protocols. Use OPC UA for its flexibility and security, setting the update rate to 100 milliseconds for real-time data exchange. Next, implement edge computing to reduce latency. Deploy microservices at the edge, processing data locally before sending it to the central system. This reduces network load and speeds up decision-making. Additionally, leverage machine learning algorithms for predictive maintenance. Train models using historical data, focusing on parameters like temperature, vibration, and operational hours. Set alert thresholds to notify maintenance teams before equipment failure occurs. Finally, ensure robust cybersecurity measures. Use encryption for data in transit and at rest, and implement multi-factor authentication for system access. These advanced strategies will help you achieve maximum efficiency in your IT/OT integration. Navigating the integration of IT and OT systems is not without its challenges. One common pitfall is the misconfiguration of communication protocols. Ensure that your PLCs and IT systems are using compatible protocols, such as Modbus or OPC UA. Another frequent issue is latency, which can significantly impact real-time data processing. To mitigate this, optimize your network infrastructure and consider using dedicated industrial Ethernet switches. Security is another critical concern. Always implement robust authentication and encryption measures to protect your systems from cyber threats. When debugging, start by isolating the problem, check your PLC logic, network connections, and IT system configurations. Utilize logging tools to trace data flow and identify bottlenecks. Remember, the key to successful IT/OT integration lies in meticulous planning, thorough testing, and continuous monitoring.